Hello guys, welcome to Solving Solutions on one channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to take this process to another level. We have so far been able to get the distance and bearings from our coordinates, right? Good. So we are going to convert the coordinates in decimal degrees to what? Degree, minute, and seconds. And then we are also going to use the coordinates we have gotten to also calculate the area, right? Good. Using the coordinate method of maybe using the cross coordinate method, right? Good. So we have our coordinates here, and then the order of operation is always 2 minus 1, 3 minus 2, and the rest of that. Therefore your delta eastings and your delta northings will be gotten in that manner, right? Good. So it will be easting 2 minus easting 1. So if you click on your first delta easting, you will see something like this, and then that's how the process continued to the end. Now when you come to the distance, it's simply what? The square root of your change in northing squared plus the change in easting squared, right? Good. So that's why you can see I3 minus I2 plus J3 minus what? J2. So the formula for delta northing is actually using the direct difference, right? Good. Not the difference as it is being displayed here. So that was how it was written. And then for the bearing, we now have what? Quite an interesting one, whereby we used mode and then the degree, right? Good. So which ensures that all our values are within 360, and then when the bearing that will be returned is less than 360, rather 360 is being added to it, right? Good. Then the degree function here converts the arctan result that will be in radians to degrees, right? Good. So that's how the bearing is being determined here. It also considers the quadrants where each of the bearings fall, right? Good. So normally you can have the first, second, third, and the fourth quadrant depending on the sign of your delta northings and your delta eastings, right? Good. So the arctan actually considers that. Therefore, there will be no need for us to add 180 or 360 or as the case may be. The 360 we are adding here is just for a general condition whereby if the bearing is negative, 360 will be added to it, right? Good. So that is for the bearing. Now coming to have our bearings in degree, minute, and seconds. Sometimes while you're working, you would not need your answer to be in decimal degrees. You would need it in degree, minute, and seconds. So for us to achieve that, we now had to extract our DMS from our DD. The first thing is to find the integer value of our result in decimal degrees, right? Good. So you now see that for D, the formula is for the integer of what? E3, which is this, right? Good. Then for the minute, it will now be integer into our bearing in DD, which is this, right? Minus the integer value that we have gotten. So what this simply means is that we still need our result to be in integer, right? Good, because we need a whole number, right? Good. So that's what this int does. The int function returns what? The integer value of what? The argument that is inside of it, right? Good. So instead of it to have decimals, it will take everything to the nearest whole number. So that's why we still have the integer here. Otherwise, we could have simply said what? E3 minus B2 times 60. So E3 is the value in decimal degrees minus B2, which is what? This value we have gotten times what? Times 360. That will return what? Our minute value, right? Good. Then finally for the seconds, we have done similar stuff. However, we did not use the integer value. We only rounded it to the nearest what? 2 decimal places, right? Good. So that's what this round does. What this round does is that whatever result that is being returned in this our argument is being rounded what? To 2 decimal places. So if you decide to take this to 0, you will find out that we have all our values in what? In whole numbers, right? Good. So there will be no decimal. Are we together? Good. So but for the purpose of the formula, let's still leave them as in 2 decimal places. So this is how we have been able to, from the coordinates, got our distances and the bearings, and ultimately express the bearings that were in decimal degrees to their corresponding DMS values. Now this program is available for download, so you can check the description section of this particular video. You would see a link that will direct you to downloading this powerful Excel program, right? Good. So we have also kept these 2 columns for your check. Now we used a closed traverse or a closed loop, right? Good. In that we started from PT1 and then we also ended at what, PT1, right? Good. So it forms a closed loop. So for any closed loop, if your data set starts from same point, from a point, and then closes on that same point, you can have what, the check of your delta easting and your delta northing, which the algebraic sum must be equal to 0, right? Good. So if you click on this cell, you are going to see that this gives you what, the algebraic sum of all your delta easting. So depending on your data value, you can decide to, either drag to fill or maybe drag to reduce, depending on what the number of data that you have, right? Good. So similarly, if you do that for the delta northings, you are also going to see that what, it highlights everything that is under the delta northings column, and then it gives us what, 0. This shows that the value we have gotten for our delta easting and our delta northings are actually correct, right? Good. So whatever alteration you perhaps are going to do to any of the column, you would see will definitely affect what the result that you have here, right? Good. Because this has now introduced an error to our system, right? Good. Then finally, before we leave, we can decide to also check what the area computation, which is very interesting and straightforward. Now we have picked all of the coordinates that we have on this first sheet, and then we have about 1 to 51, and then we need to repeat what, number 1 again, right? Good. So that is what we have simply done here. We have about 1 to 51, and then we have what, repeated 1, right? Good. So the order of operation, it will be this multiplied by this multiplied by this, right? Good. So we now have that cross, or maybe the scissors operation. So this is multiplying this, and then this is also multiplying this. So when you open the first area, you are going to see the order, right? Good. So we have B2 C3. If you come down, we have B3 C4. If you come down, we have B4 C5 down the end, right? Good. So when you come to area 2, we have what, C2 B3. You come this way, we have what, C3 B4. So it goes this way and then it comes this way. So at each point we are given what, the value of an area, right? Good. Okay, let's do something now. Let's say equal to this multiplied by that. Good. So we don't want it to be in this exponential form. Therefore, we now formatted our result so that you can see the number displayed normally, right? Good. So right click, format cells, and then since it's in general, we come to number, then we take it to 3 decimal places, and then we click on OK. So good. So it now returned what, the area, the product rather, of the 2 coordinates as what, a complete number, unlike when it was in exponential form, right? Good. So this will help you if perhaps you need to attach this to your report, or maybe if you want to write it out or something. So you don't usually, or no, you won't write e raised to power 12 or the rest of that, right? Good. That will be used during computation, but in presentation, it's always best that you display the values like this. So that was how we formatted what, all of the values that we have in this column, and then the values that we also have in this column, so that we can have what, the real numbers like this. So having done that, we are going to add what, all our area 1 together, and then we are also going to add all our area 2 together, right? Good. So we have it at the end of area 1 and area 2, but we thought that perhaps if your data set exceeds what we have used for the demonstration, you can always have it by the side, right? Good. So this will now be equal to the sum of your area 1. So as we have told you earlier, if it is more, you just drag down to fill, and then if it is less, you just drag up, right? Good. So this will give us what the value for the sum of all the area 1. Then we still come up to area 2, and then we do similar stuff, right? Good. So okay, this area 2, and then we now also drag it down to the end. So we now have all of the values of area 2. So finally, the area would now be the absolute value. Now, the reason why we use absolute here, ABS, is that we don't know which one is higher. So whatever the value of H3 and H4 that we have, which is our area 1 and our area 2 respectively, whichever is higher, by the time the subtraction is done, we don't need a negative value, hence the absolute. So when you subtract, it will now be area 1 minus area 2 divided by 2. That will now give you what the value of your area. So this value here is what you are now going to add to your report, or maybe whatever you're having as what the area of the parcel in square meters, right? Good, because the units that we are having here are all in square meters. So if you perhaps want to convert it to maybe hectares or thereabout, you see this value divided by 10,000, if I'm not mistaken. So it returns what the corresponding area values, right? Good, in hectares, right? Good. So you can use this this cell to convert you can use any other cell rather to convert your area in square meters to other equivalents, right? Good. So we have shown you exhaustively on today's tutorial how to use this application, which you can download via the link provided in the description section, right? Good. How to carry out back computations, displaying especially your bearing in degree meter seconds, not just in decimal degrees, and going further to also get your area using the coordinate method, right? That's the cross coordinate method. There are some key takeaways. By the time you open the formula, you are going to see the program, rather you are going to see the different formulae that we are used, and then perhaps it will help in making decision, building more, or maybe modifying it to suit what you want to achieve. So thanks for coming to class. We hope we have provided solution to this particular surveying problem. For the area, remember you can always check your value. Maybe just copy all of these coordinates, you move it to AutoCAD, which is very easy, and then you try to check the area that you've gotten, right? Good. So you can do that to always check whatever you have done, because we have told you that whatever value you have with a formula that you wrote in a program, ensure that you use a more known base, right? Good, to check before you deploy it. So we have done that for our bearings. So we are going to see you on the next tutorial. Ensure you keep staying safe and have a very good time. Bye.